How many rational numbers are there between 1 by 7 and 5 by 7? Between 1 by 7 and 5 by 7. 5 by 7. So how many numbers can we find? How many rational numbers can we find between the two? Well, let's list down some of the obvious ones. So 1 by 7 is less than 2 by 7, and then that's less than 3 by 7, that's less than 4 by 7. Right? 2 parts out of 7 is more than 1 part out of 7, and it's less than 5 parts out of 7. So we have 2 by 7, 3 by 7, and 4 by 7. So we have found 3 rational numbers. Now, is that all? Well, let's look at this. Let's look at equivalent forms of the two given rational numbers. So 1 by 7 is also equal to 1 times 2 divided by 7 times 2. So I'm multiplying both the numerator and the denominator by 2. And the number does not change when I do that, right? Because 2 divided by 2, what is that? That is 1. So when I multiply a number, in this case 1 by 7, when I multiply that by 1, the number does not change. So now what is 1 times 2? That is 2. And 7 times 2 is 14. Now I can do the same thing with this number 5 by 7. 5 by 7 is equal to 5 times 2 divided by 7 times 2. And that is equal to, what is 5 times 2 is 10. And 7 times 2 is 14. So now if you look at these two numbers, how many rational numbers can I find between this guy and this guy? I can write them down. I can find 3 by 14, 4 by 14, 5 by 14, and so on and so forth, all the way until 9 by 14. So now I've got 3, 4, 5, 6, 7, 8, and 9. So that's a total of 7 rational numbers. First off, we just found 3. Now we found 7. Now I could repeat this procedure with a different multiplier. Let's say I chose a bigger integer to multiply with. Let's say I chose 3. So what would I get? 1 by 7 is the same as 1 times 3 divided by 7 times 3, and that is 1 times 3 is 3, 7 times 3 is 21. And what is 5 by 7? 5 by 7 can be written as 5 times 3 divided by 7 times 3. And that is equal to 5 times 3 is 15, 7 times 3 is 21. Now if you look at these two numbers, how many numbers can I find between the two of them? There's 4 by 21, 5 by 21, 6 by 21. I can keep going all the way until 14 by 21, right? 14 is 1 less than 15. So if we count this out, that's going to be 11 numbers. Interesting. So first we had 3 right here. Then we found 7, and now 11. So if I were to multiply, so what we see is, the bigger the integer, in this case it was 2, and then the next case it was 3. The bigger the integer, the more numbers I find. If I were to choose, let's take one last example. If I were to choose 10 as a multiplier, 1 by 7 is the same as 1 times 10 divided by 7 times 10, and that is 10 over 70. And 5 by 7 is the same as 5 times 10 divided by 7 times 10. So that is equal to, what is 5 times 10? It's 50. 7 times 10 is 70. So now between these two guys, looks like we can write down a lot of numbers here. 11 by 70, 12 by 70, 13 by 70. I can keep going all the way until 1 less than 50, which is 49 by 70. If you were to count these out, that would be 39 rational numbers now. So what we see is the bigger the multiplier I choose, the more rational numbers I can find between the same pair of rational numbers. So is there a limit to how big a multiplier I can choose? Well, no. I could have chosen 100 or 1,000 or 1,000,000. So the bigger the number I choose, the more rational numbers I can find. What this means is that I can actually find as many as I want, countlessly many rational numbers between this given pair of 1 by 7 and 5 by 7. So there are, to answer this question, there are countlessly many rational numbers between 1 by 7 and 5 by 7. In fact, this result applies to any given pair of rational numbers. It could be anything other than 1 by 7, 5 by 7, and the same logic applies. I can find countlessly many rational numbers between any given pair of rational numbers.